Hello, this is Tim from AACC Mechatronics. This is Joe, and we have Peggy. Peggy is a Mechatronics student studying programmable logic controllers, and this is her final PLC project, or so she says. So this looks like sort of a cube to me with lots of wires running everywhere. So what actually is this, Peggy?
This is actually a parking garage simulator that we have to operate.
Okay.
On the side we have a PLC that we've actually programmed and wired. It's hooked to several sensors on this side of the unit, and we have a relay also that's going to control these motors so we can lift them up and down. But basically what happens is we put one of our toy cars in the lift, select the floor, the disc will rotate to find the open slot, and then
Throws it in there. That's great.
And then reset to its initial position.
Okay, so can you tell us some of the sensors that are on the train or the parking garage? What sort of sensors do you have?
We have 3 limit switches to detect the actual levels that the lifts rise to, so that we know which level of the parking garage we're actually on.
Yep.
We have another switch on the top that tells us as the disc turns as where the slots are located, so we can keep track of that.
Yep.
We also have, this is an infrared sensor on the right that will detect whether or not a car is actually present in a slot. We also have a relay on this side of the unit. Because we're using DC motors to control the lift, we have to be able to reverse the polarity, and that's what that relay does for us.
That's awesome. Yeah. So this looks like the main PLC here. It's Alan Bradley. How did you guys program the parking lot?
Well, we use something called RS Logix. That is their software interface that you use to actually program the Allen Bradley units. You create the program here, download it onto the PLC, and then you do your testing.
But this doesn't look like programming at all. It looks very different. When I think of programming, I think lines of code.
Well, this is your ladder logic.
Okay.
This is not your high-level programming languages. This is what engineers use to program the electronic units, so to speak, the electrical units.
Okay. What else? Can you tell me anything else about the project? Was it a good experience? Did you get much out of it?
Oh, absolutely. It gives you a real-world experience, as opposed to working with a simulator. You actually get the experience of hooking up to the PLC itself, learning how to get the software to interact and talk with the PLC. That's something that we don't always do when we're just working in a simulation environment. And being able to actually hook up the inputs and outputs and getting them to actually operate with the unit.
Okay. How did you guys actually? How does this lift actually work? And how does it looks like it's pushing the cars into the, I don't know what you'd call that.
So I designed it such that it has 2 DC motors on either side using a rack and pinion drive. And the actual ejector of the car is a pneumatic cylinder. It's a single acting cylinder with a 3-2 valve, directional control valve. And we have air coming in, and it's solenoid operated. So the solenoid will be turned on and off via the PLC.
Yep.
And when it's turned on, it will eject the car. When there is no power on the solenoid, air will not be going through the valve, and a spring will return it to its initial position.
Gotcha. Well, I think that's a pretty amazing project. Joe has built 4 of these trainers, so that's just one of them there. This is our Mechatronics lab here, so if I swing all the way around, there's another three trainers that Joe has built, and we're planning, I have a feeling you guys are going to be using those tonight. So have you with the PLC class. Do you guys have anything to add? You're happy enough?
Happy enough.
Alright, good job, thanks.